Let's solve some exponential equations. An exponential equation can have the unknown, the bit that you're trying to find, either in the base of the equation, in which case we would have to make the power of that unknown 1, or the unknown might appear in the index of the equation, in which case we need to express both sides of the equation to the same base. Let's have a look at some examples. Starting with this one here, we see that the x, the unknown here, is in the base, and we really want x to the power of 1, so we have to undo that power of 1/3 that we have there, which we do by cubing both sides of that equation. And so to cube both sides, we'll end up with 3 times the 1/3 is x to the power of 1 is equal to 3 to the power of 3, which is 27. Once again, we've got x as a base. We're raising it to a power and then multiplying that by 80. So in order to solve that, then the first thing we've got to do is undo the times 80, that is divide by 80. And simplifying that, we will get x to the power of 6 is 9/4. Now we can solve that by taking the 6th root of 9/4, which we can do on our calculator. That'd be the same as raising it to the power of 1/6. Or we can be really clever here and say, well, taking the 6th root is the same as taking the square root and then taking the cube root. And we can see that we can take the square root of the 3/4 would be 3/2, and that will then leave us with the cube root of the answer of 3/2. But it is okay just to simply work out from our previous line there what the 6th root of 9/4 is using a calculator. We'll now move to having the unknown in the index of the equation. So to solve this one, what we need to do is to see if we can write the 32 to the same base as what we've got on the left-hand side, the 2 that is. And of course 32 is 2 to the power of 5. That means that those two indices there must be equal, seeing that we have the same base. So 3x plus 2 has to equal 5. Solving that, we'll have x equals 1. In this example, once again, we have our power in the index. Notice that we don't actually have the same bases this time, but the 25 can be written as 5 squared. So we'll start off by rewriting our 25 as 5 squared. We can now use our index law that says we multiply those two powers when we raise it to a power and then to a power again. And that'll give us 4x minus 6 there. And once again, seeing that we have the same base on left and right hand sides, we can equate those two indices. Solving that, we'll have 1x left here if we subtract 3x from both sides, and the 6 we can add to both sides, which will give us an x equals 5. Again, we have x, our unknown, in our index, but we observe that our bases are different this time, and we can't write one in terms of the other. And so to solve this, we need to take logs of both sides. So we'll leave this sort of problem until after we've looked at logarithms. So we've seen that exponential equations can have the unknown in the base, in which case we have to undo the exponent. The exponential equation can also have the unknown in the index, in which case we want to express both sides of the equation to the same base.